You type a normal sentence into ChatGPT, maybe just 10 words, but internally the engine reports 17 tokens. Not 10 words, not 10 characters, tokens. So, what exactly is a token? Why is it a fundamental unit of LLM computation, and how does it dictate your API cost, latency, and context limits? Today, let's go under the hood. A token is the smallest unit of text that a language model can see. Sometimes one token is a whole word, but often it's a subword, a piece of punctuation, or even a specific whitespace character. Unlike humans, AI doesn't perceive language as fluid sentences. It perceives it as a sequence of discrete, manageable chunks. Neural networks don't read English, they perform high speed matrix multiplication. Before a model can process your text, it has to convert it into a format it understands, that is, numbers. And each word is mapped to a unique token ID, let's say like hello becoming 15339. These IDs are then projected into a high dimensional vector space, also known as embeddings, allowing the model to calculate the mathematical relationship between words. This is a standard ingestion pipeline. First, the tokenizer breaks your string into raw tokens. Next, those tokens are swapped for their corresponding integer IDs from a predefined vocabulary. Finally, those IDs are converted into embeddings, that is, dense vectors that capture the semantic meaning before they ever hit the first layer of transformer. Tokenizers are trained to be efficient. Common words like computer are indexed as single token. However, if you throw a complex word like internationalization at it, the tokenizer splits it into subunits like inter, nation, and allyization. This allows the model to handle an infinite variety of words, even typos, using a finite vocabulary of around 50,000 to 100,000 tokens. Most of the modern LLMs use byte pair encoding or sentence piece. Instead of a fixed dictionary, these algorithms start at the character level and iteratively merge the most frequent adjacent pairs of tokens found in their training data. It's essentially a compression problem, like how do we represent the most information using the fewest number of tokens? But here's where it gets tricky for developers. 100 characters of plain English might be 25 tokens, but 100 characters of Python code or a language like Chinese might result in a higher token count. Special characters, brackets, and different script encodings change how a tokenizer fragments the data, which means length is never a reliable proxy for the cost. Tokens are the currency of AI for four reasons. Cost, that is, APIs bill per token because they represent GPU cycles. Speed, LLMs generate text autoregressively, one token at a time. Third is context window. This is the model's RAM. Once you hit the token limit, the oldest data is purged. Then fourth is compute. The self-attention mechanism scales based on the number of tokens it has to compare. In a production environment, you're built for the round trip. If your prompt is 800 tokens and the AI responds with 400, you're built for 1200. This is why prompt engineering is often just an exercise in token efficiency. That is, we are trying to minimize the input noise to maximize the quality of the output within the model's hardware constraints. So the next time you're chatting with an AI, remember, it isn't reading your story. It's converting your text into vectors, analyzing those vectors through layers of attention, and statistically predicting the most likely next token in the sequence. Understanding the token is the first step in understanding how modern large language models actually function under the hood.